Alright, for the chart right, what questions do we want to see you go over? I see 2s and 3s. And then it's a tie between 1 and 5, so everyone choose 1 or 5.
What's the...
Doesn't matter, just choose 1 or 5. Everyone choose 1 or 5.
I'm supportive. Can you be supportive or not? Like, hey. Put your 1 up.
1 and 1. So 1, 2, and 3.
It's not hard.
It's not hard.
Alright, for number 1, the x-intercepts, we're just looking for where does this cross the x-axis. And writing those as order pairs. So -1, 0, and 5, 0.
Do we have to put that X back?
No, you just need the order pairs. Okay. For number 2, translating is not something you can do in Desmos. You have to know how to translate. For less than a number, you know that's going to be that turnaround phrase. But because of where this comma placement is, all of this is going to be Q with +3 at the end.
You put a plus.
So depending on where the commas are, if it said for less than a number Q, comma, then the X would be Q. But because it's after all of that is being Q. And then the +3 goes outside of that. Questions on that? Great, and then number 3, find the line of best fit in Desmos. There we go. And then if you found the line of best fit, that's your using your x1, y1.
You say you're wrong?
Y1. Squiggly line the tilde. mx1 plus b. And then use 3 decimal places, so y equals -0.503, x plus 15.73.
I know.
Oh, okay.
You get it wrong.
No, it's just that. I didn't know which one was on the Yeah,
Questions on that one? Make sure you hold on to this shortcut answer sheet. This one will also be formative once we finish through 40. And then everyone look at your notes. And go grab an iPad if you haven't. For quadratics and exponentials. Get your iPad kind of studies. But using this data, what's on the front of your paper, go into stat. Actually, reset your calculator first. Let's do that first. Second plus 7, 1, 2.
What?
Second plus 7, 1, 2. Reset your calculator. Alright, so go into stat. Go look and see if there's an extra battery vector.
Yeah.
I meant to have this in front of me, but I don't. Start typing in your numbers in L1 and L2. You get all of your
What's that? And then there's only two. One L.
In L1 put your X's, and L2 put your Y's. And then I'm following the rest of these steps. Go back into stat, scroll over to calculate, and then instead of number 4, our linear regression, we're going to go to number 5, quadratic regression. This part is the same. We want to find the curve of best fit and predict some value, so I'm going to go down to store regression equation, hit alpha trace, and enter 3 times. So just like your line of best fit, your curve of best fit fits your data the best as possible to whatever curve you put. Later we'll do that. So let's go ahead and write this in the curve of best fit. Spot. So y equals negative 1x squared. Or just negative x squared. There is no b, so you can put plus 0, or you can just leave that off, and then plus 7. Say that one more time. It is a trinomial. I'm sorry, no, this one's a binomial, but it's still quadratic. But we're not factoring, so that part doesn't matter. So then we're going to predict the y value for an x value of 3 and 4. So you can do one of 2 things. Since we stored it, go into the table and look for when x is 3 and when x is 4 and write those down. Or you could go into the home screen, second mode, and store this. So 3 store x. And then go back and grab your equation and alpha trace. The table is probably just easier to see it from there, but you can do it either way. So then the value of 3 would be what? Negative 2, and the value of 4 would be what? Negative 9. I know we did that kind of fast because some of that is really just the same as line of best fit. Just the curve of best fit has more. Now let's do this in Desmos. Yeah, so it's the same data set that we're doing in Desmos. You need a table, so just like line of best fit, put in your data. I zoomed it in, but I really didn't even need to do that because I can see it's making that U shape. And then to get our actual equation, just like our line of best fit is basically our equation of a line, but with x1 and y1 and the squiggly line, our quadratic equation is similar. So start off the same, y1, and it's on your notes also. The squiggly line, the tilde. And then here, just be careful. So type in a x1 squared. And then plus bx1 plus c. And that would give us our quadratic curve of best fits, which was the same equation that we had before. Questions on that? Great. Now on the next page, we're going to do exponential regression in the calculator first, and then in Desmos, and then after that, you can choose how you want. So I'm going to go back to Stat, go back to Edit, clear out my list by going up to the top and hitting Clear, not Delete, and do that with the other one as well. And then put in these new values. So I don't know if yours will let you do this, but you could do it in fraction form or in decimal form, it doesn't matter. What pattern is happening in our lives? By 2. So there's going to be a 2 somewhere in our equation. So then go back into Stat, over to Calculate, and then we're going to go all the way down past 0 to exponential regression. So 0 is your exponential regression, and then same as before, go down and store this in alpha trace. I forgot to show that in Desmos. We'll do that for this one. And then calculate. Okay. So then our curve of best fit, we have to put it in this format, a times b to the x. So this would be 1 times 2 raised to the x, or just 2x. 2 to the x. And then if we were to predict the value, we'll do 2 of these in the calculator and then the other 2 in Desmos. So if I go into my table or I store the value, the y value for 3, when x is 3 is what? 8. What about negative 3? Or whatever that is as a decimal. So now in Desmos, we're going to do the same thing. You can use the same table you had and just change the values or delete everything. That's completely up to you. I'm going to get rid of that other equation we had. So I see it's making that curve. If I zoom in, the curve's a little wider. And then on the back of this page shows your equation, similar to the other one for using x1 and y1 and the tilde. So y1 tilde a b to the x1. And it's going to give us the same thing. And if I wanted to find when the y value when x is 4 or negative 4, I could type in x equals 4 and find that point. So that y would be 16. And then I could also change that to negative 4. And whatever that is in this one. Or you could just leave it as this one. So 16 and 0.063. Do we have any questions on how we find the quadratic or exponential function, curve of best fit in calculator or Desmos? So, like the line of best fit, you'll be able to use Desmos. It will be an actual test this time, not a project. And you'll have a choice whether using the calculator or Desmos. Go on to the next page. So this is just comparing all of them because it may not say use the curve of best fit, use the line of best fit. You have to figure it out. What is it? What are we using? All of your regular equations in standard form are given, and then the regression equation in Desmos is also given. You will need to know those for the SOL and for the test. And then there's some typos that I realized later. So in number 1, change this point to 1, 1, not negative 1, 1. And then we're going to graph all of these points. So go ahead and start doing that. And look back up here. We should be able to see which type each graph makes, linear, quadratic, or exponential. What would number 1 be? Linear. It's a line. We're not going to make the equation of a linear because we did line of best fit already. We just need to know that this would be linear. For number 2, quadratic. We are going to find that equation, but in a moment. And then number 3. Excellent. Now, if you were just looking at the points and maybe didn't have a graph to graph it, I mean, you could always put them into Desmos. But if we were just looking at the points, as I'm looking at these, my x's are increasing by whatever amount. And my y's are also increasing by that same amount. So because that's a consistent increasing of y over x, that would be slope linear. But in number 2, I see my x values going up by 1, but my y values go down and then come back up. That's going to be quadratic. Anytime you see something that goes down and goes back up or vice versa, quadratic. Exponentials most of the time will have fractions, and that should tell you, but quadratics could also have fractions. So I would look and see, are your x values going up, and are your y values keep going up or keep going down, or do they come back up and go back down? That would show you the difference. So if it goes up and down or down and up, quadratic, but if it just goes up or down in one direction, exponential. Right. Let's do this. This side of the room, find the quadratic equation. This side of the room, find the exponential. So put in your ordered pairs into your calculator or into Desmos. Use your equation and find what that equation is.
You have the quadratic equation.
You heard it from and then I just need the quadratic from someone over here. Y equals is it 1x squared? Is it 1x squared? Yes.
Sure.
Okay, and then x
Plus 2x.
plus 2x plus minus
It's a negative.
minus 1. I just couldn't hear your number, sorry. Like this. So as long as you know your equations, you can find quadratic and exponential curves. Hold on to this. We're going to do a couple problems from this tomorrow and then some SOL practice.